All right, today we're going to look at lesson 3-4. Today, what we're looking at is not just sine and cosine function values as we've been doing, but we're going to continue on and looking at their graphs. So how does it look as a graph? That's kind of the goal today. So last class, we were looking at their values. Today, we're going to look at how we put together the graphs, how they look. So first, some visual vocabulary to go with some words you're going to hear me say today. First, the sine function. Whenever you hear me say the sine function, I would be talking about which variable. Sine is what letter? The y. Sine is the y variable. What the sine curve is going to look like, or the sine function, when you graph it, is going to look like this. It's going to look like a snake. It originates from the origin. It goes up to its maximum. It'll go down to a minimum, and then it'll return, and it'll continue on this pattern. So I'll just draw an arrow here. That's when it'll, that's one complete period right there. That's one period, which means a completed cycle. Notice that the sine function will start at the origin. So if you want to put point there, that's 0, 0. We'll learn it has a maximum at pi over 2. So I'm putting this in as if it's these points I'm representing as theta comma y. So all these points I'm writing out as the theta comma the y value here. It'll be at pi over 2, and its maximum value, if it's just the sine function, is 1. Sines is bounded between the values of -1 and +1. That means in the range, it gets as high as +1, it'll go as low as -1. Now, we have a 0 here. The 0 occurs at pi radians. The minimum, if you look at it, it goes from 0 to its maximum at pi over 2. That means half a pi. Its maximum is half a pi. It comes back to 0 at 1 whole pi, which is 2 halves. So this is 1/2, 2 halves. How far do you think this is? 3 halves, that's right. And so the way they'll write this is 3 pi over 2, but that just means 3 halves. And that minimum value is -1. There we go. 3 pi over 2, -1. And then finally, we complete one whole period. Let's see here. That's 1 halves. 1 whole is 2 halves. That's 3 halves. How far do you think it takes to complete one whole cycle? 2 pi, which would be 4 halves. At 2 pi, it returns to 0, and it starts the process all over again. So if you want to note this, the period is 2 pi. For the sine function, the period is 2 pi. The amplitude, do you remember what amplitude meant? It's the difference between the maximum and minimum divided by 2. Or you could say, whoops, from the midline up to the maximum, or the midline down to the denominator, or the lowest, I'm sorry, from the midline to the minimum. That distance. So what's the amplitude here? 1. The amplitude is 1 unit. Okay, so that's what the amplitude would be, this distance from here to the midline. Right there, that's the amplitude of 1 unit. Has a distance of 1 unit. So that's the amplitude. The period is how long does it take to complete one whole cycle? That is 2 pi radians. Okay. The sine of theta, like it says here, it's the y coordinate. When we look at the unit circle, let me show you a picture of the unit circle. When we look at this unit circle here, the sine is always the y variable. So as you look at a unit circle, sine is represented by the y value on the unit circle. Okay. So that's what that's telling you there. All right, with that, we're going to begin our graphs, and you're going to see how these work together. I have a pretty cool tool to show you at the end of class. So first, it says, since the period of the sine function is 2 pi, we'll graph the function on the interval from 0 to 2 pi. So what we're going to do here is we're going to fill in this table. Now, one thing you can do is this. You could pull out that unit circle that I have given you on your desk. It's also attached to your AP Google Classroom, your Google Classroom. Right, when you log in, go to classwork. You'll see it. Let me just open up a tab and show you. If you go to your Google Classroom, you can find this. It's at the very top It's one of your resources. It's there. That's that top little resource, right? When you go to classwork, that's where you can find your copy. Now, what you can do here is you can fill in these values. Okay, and so if you're just watching this, just pause the video and go off of this. For you in class, I want to show you a way to memorize this. Okay, so I'm gonna pause this video now. Okay, so picking back up, if you're looking at your left hand, which finger would you bend for 0? Pinky. Bend your pinky. That's the 0, no denominator finger. Bend your pinky, flip your hand over. How many Y fingers do you see there? 0. So what this means is this value here would be the square root of 0 divided by 2 because there's no fingers for Y. Now, what is the square root of 0? 0. And what's 0 divided by 2? 0. There we go. Okay, turn your hand back over, looking at the palm of your hand, palm of your left hand. What finger would you bend for pi over 6? You bend your ring finger. Bend your ring finger, flip it over. How many Y fingers do you have there? 1. So it'll be the square root of 1 divided by 2. Sine and cosine are always divided by 2. Now, what can that reduce? Yes, 1/2. Okay, what about pi over 3? Now be careful. Which finger is pi over 3? It's the index. What was the middle finger we just skipped? Pi over 4. We skipped pi over 4. Pi over 3. Okay, bend your pi over 3, your index finger, flip your hand. How many Y's do you have there? 3. So it'll be the square root of 3 divided by 2. That cannot reduce. Okay, now what about pi over 2? Which finger is that? Thumb. Bend your thumb, flip your hand. How many Y fingers do you have there? Square root of 4. And you're going to divide that by 2. It's 2 divided by 2. What's 2 divided by 2? 1. There's the value there. Now, we are getting into the second quadrant. How do I know this is the second quadrant? Because these values are almost 1 whole pi, which means we're now in the second quadrant. So now, then which finger was pi over 3 again? Index. So 2 pi over 3 is still your index finger. Bend your index finger, flip your hand over. What do you get there? Square root 3 over 2. And you should see the pattern. The value should count up to +1, then they should count down all the way to -1, and then back up. It just goes in that pattern. So this is square root of 3 over 2. Can that reduce? No. Okay. 5 pi over 6. Which finger would you use for 5 pi over 6? The ring finger. And since we're in the second quadrant, I didn't finish this thought. Since we're in the second quadrant, the way it works is on the circle. Second quadrant is above the x-axis, which means the Y value is positive. These are positive values for sine because you're above. Sine is positive here. Sine is greater than 0 when you're up top. When you're down low, below the x-axis, sine is negative because sine is Y. Okay, so this is positive values. Okay, so that's square root of 3 over 2. Which finger did you bend for 5 pi over 6? Which one did you say? Ring finger. Bend your ring finger. Flip your hand. How many Y fingers do you have left over? 1. It's the square root of 1 over 2. The square root of 1 over 2 is, what's the same thing as square root of 1?
1 over 2.
It's just 1 over 2. All right. Pi. Which finger would you bend for pi? Pinky. Bend your pinky. Flip your hand. How many Y fingers do you have? 0. So it's the square root of 0 over 2. What is the square root of 0? 0. Divide that by 2. 0. There you go. So notice we counted up 0, 1/2. Square root of 3 over 2, 1. We counted up, or you could say 0, square root of 1, square root of 3, square root of 4, square root of 3, square root of 1, square root of 3. We're going down now. So the next one's 7 pi over 6. This is now more than 1 pi. Which quadrant are we now in? Third. So these will be negative values. So 7 pi over 6. Which finger is that? Ring finger. Bend your ring finger, flip your hand. How many Y's do you have there? 1. So it's the negative square root of 1 over 2. It's negative because you're in the third quadrant, where Y's would be negative because it's down below the x-axis. Now that can reduce to just become negative 1/2. Okay. 4 pi over 3. Your turn. 4 pi over 3. Which finger is that? Index. Bend it, flip it. How many Y's do you have there? And again, we're in the third quadrant, so we need to be negative. So it's negative square root of 3 over 2, which does not reduce. Okay, what about 3 pi over 2? Which finger is that? Thumb. Flip your hand. Again, we're down below. We are right now on the y-axis. How many fingers are left over? So it's negative square root 4 divided by 2. What is the square root of 4? 2. And 2 divided by 2 is 1. So we are now at the minimum. Negative 1 would be its minimum. As I told you, sine is bound between negative 1 and 1. Its range values are bound. Okay, 5 pi over 3. We're now in the fourth quadrant. We are almost 2 whole pies. Which finger is 5 pi over 3? Index. Bend it, flip it. Again, this is negative. Negative square root of 3 divided by 2. That does not reduce. Last two. 11 pi over 6. Which finger is your pi over 6 finger? Ring. Bend your ring finger. Flip your hand. How many fingers do you have for y? 1. So square root of 1 over 2. What is the square root of 1? So it's just negative 1 divided by 2. And finally, 2 pi. Which finger is the no denominator finger? The pinky. The pinky. Bend your pinky. Flip your hand. How many y fingers do you have left over? 0. So it's the square root of 0 over 2, which is. Now, is that a positive 0 or negative 0?
Well, no. 0 can't be negative.
Trick question. 0 is
0.
0. It's neutral. Okay, so there's our values there. There was no pi over 4s, couldn't fit it in the chart. So I skipped the pi over 4s. Notice what happens with the sine values. They count up because as your angle, check out my picture right now if you're not looking at it right. As your angle moves around, what's happening to my y values as I go around right now? They're increasing. And now what are they doing? Decreasing, 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 decreasing. And now what? They're increasing. So they follow a pattern. It comes up and at the same speed it increased, it now decreases. And it goes around from its maximum being at pi over 2 to its minimum at 3 pi over 2. Its maximum was at pi over 2, 1 unit high. That was its maximum. Its minimum was at 3 pi over 2 when it was at negative 1. And so it just follows the same pattern over and over and over. Okay, state the intervals of x where the sine function is increasing. Okay, I just told you where it's increasing. Tell me, when do we start increasing? Well, let me go after you make one full pass or whatever. Where does it start increasing from? From its minimum here, and it goes up this way. So it starts increasing from, you could call this negative pi over 2. So, and I'm going to add in something in a second. It's going to start increasing from negative pi over 2. That means that if I didn't start at 0, if I backed up a little bit, that would be negative pi over 2. It goes from negative pi over 2 until what value does it increase? Stop increasing.
Stop increasing?
Yeah. At pi over 2 is where it stops increasing. So this is normally the interval where it would be increasing from. Now, it can do this over and over again. So here's what I'm going to do here is I'm going to write down plus 2n pi. 2, let me do 2 pi n actually. 2 pi n. What that means is you can do this infinite number of times. Just as long as you add a full period to it, it starts back over. So we increase, whoops, when you increase, you don't do a bracket, you do a parenthesis. From negative pi over 2 plus 2 pi n. That means you can do this infinite number of times. And we decrease, we continue increasing to pi over 2 plus 2 pi n. Now, this would be for the sine function, not the sine function that's restricted here. That would just be in general. It would always increase there. That's where it's increasing. Ran out of space there, increasing. Now, decreasing. Where did our function start decreasing?
Pi over 2.
From pi over 2. And how long did it continue to decrease? To this point, which if I'm going forward, I'm going to call that 3 pi over 2 now. Okay, so I decreased from pi over 2. And again, it would do this repetitively. So I'm going to put 2 pi n here. And it stopped decreasing at 3 pi over 2. Now that's would mean it's true on any interval, not just the interval that they were given to us originally. If you wanted to look at this problem and increased originally from 0 to pi over 2, then this area, it decreased. And then we start increasing again if you only wanted to look at these values. Now tell me about this. Where's the maximum occur at? Where do we say the maximum occurs at? Where was the maximum on this unit circle? Where is the highest y value? At any pi over 2. And it's not just pi over 2 and only pi over 2. And every time you would do a full 2 pi's, making a full revolution, you'd have another one. So put 2 pi in. And where would its minimum be?
Negative 3/9. 3 pi over 2.
Actually, let me put the,
It's a pi.
if you want to do this as a coordinate point, so that's the x value, and the y value would be comma 1. Okay, the minimum. Okay, 0 is not its minimum right there. That would be a 0, but not a minimum. What's this lowest point right down there? What value is that in radians?
3 pi over 2.
It's 3 pi over 2, that's right. So any multiple of 2 pi that goes into 3 pi over 2 would satisfy a minimum. And that minimum would be how low? -1. There you go. This is for all 4 of these, where n is any integer, meaning positive or negative whole number. Okay, so with that was the sine function. Now let's look at sketching some things with the sine function. To sketch the graphs of the basic sine and cosine curves by hand, it helps to know the 5 key points in one period. Now, what are we talking about when I say 5 key points? The intercept, specifically, what is an intercept?
Where the y, where the point is about to go to the x and y.
Yeah, anywhere that the graph intersects the x or y axis. Very good. Maximum points and minimum points. Okay, now for sine and cosine, there will be 5 key points in any one period. So use the table of values from example 1 to label and determine the key properties for the sine parent function. So here's what we're going to do. I'm going to label here your 5 key points. Now, the 5 key points, we had 3 zeros. You can look back at your chart. Where did the 3 zeros occur at? Origin, pi, 2 pi. That's where, from the previous, origin, pi, 2 pi. Those were the 3 zeros that the sine function goes through, that hits on one cycle. It'll always, sine functions and cosine functions have 5 key values in one period. How many will they have?
5.
5. 3 zeros. Okay, this point, what would we call this point? That's the maximum. Let's go ahead and just write these values in here. This is pi over 2, comma 1. This would be 0, 0, the origin. This is pi, comma 0. If you're wondering, where am I getting these numbers? Look on the x-axis, the x is pi, the y value is 0. And this one would be 2 pi, comma 0. And that's 4 points. We're missing one of them. What will we call this point? And it's the minimum at 3 pi over 2, comma, what's the y value? -1. There we go. So this domain, I want you to know for the sine function, the domain is all reals. So you could write it that way, or you could say from -infinity to +infinity. Now it's range. I've told it to you at least twice. I know I said it at least twice. How low will a sine function go? How high will it go if it's just the parent function of sine function? It'll go from -1. I'm gonna put a bracket because it does attain the value of -1. It's a point. It's not an arrow there. It's not an open circle. It's closed. And how high will it go?
+1.
+1. Okay. The amplitude. Remember, that's where you take the maximum y minus the minimum y, divide by 2. So the amplitude, if you had to solve it, what's the maximum y?
1.
You would subtract the minimum y, and then you would divide by 2. That's the formula. And mathematically, you are going to get 1 because what is these two negatives become a positive? So what is 1 plus 1? 2 divided by 1, 2 divided by 2 is 1. That's the amplitude. What's the period? How long does it take to complete one whole cycle?
2 pi.
Again, it's easiest if you have an extended graph to look maximum to maximum, but in this case we don't. So the points start repeating at 0 to 2 pi, so the period is 2 pi. That's the period for sine and cosine is 2 pi. By the way, tangent's going to be 1 pi when we get there. Okay, tangent only takes 1 pi to repeat. The reason being, sine and cosine take longer because to get all the positives and the negatives, you have to go around the full circle to get all of them. Because tangent is y divided by x, it's sine divided by cosine. You're going to get those negatives quicker. And so you'll have all the values repeat within 1 pi for tangent. Finally, key points. There they are. I'm just going to say labeled on graph. Labeled on graph. Well, since I'm labeling them, what would we call this point right there? A max. What would we call this one? And what are these three?
Zeros.
Zeros. Good. All right, your first DOL. I make one change to this. Okay, you can use your hand, you do whatever. I have one change to this sine function. What have I done differently this time? Okay, I hear added to. And I'm guessing what you're saying is there's a 2 in the equation that wasn't there before. But is that 2 mathematically adding?
No, it's multiplying.
It's multiplying. Is that multiplying the x values or the y values? The y values. It's on the outside. So here's what you're gonna do. You can take the same y's you had earlier. You can take your hand, bend it, whatever. But at the very end, you need to multiply it by 2, which basically means, you know how sine always gets divided by 2? Don't divide by 2. Because what is 2? You know how the values on sine normally get divided by 2? Here you're multiplying by 2. What's the relationship between multiplying by 2 and dividing by 2?
Cancel each other.
They're going to cancel each other out. So this one, you're just doing the square root of the finger all the way down. Use your hand, I recommend, just to practice it. Fill in these values and then plot the points and graph it. DOL number 1. All right, example 3 here. It says complete the table for 5 key points for sine, cosine, and tangent. So now, what I want you to do, using your hand, we're going to walk through this again. And for those of you who are just watching the video later, you can just come back, pause, look at this, take a screenshot, whatever you need to do to use this picture to help you out. But for those in class right now, I'm going to use my left hand. I'm looking at the palm of my left hand. That's what you always look at. All right, for 0 radians, which finger do you bend if it's a 0 radians? Pinky. Bend the pinky, flip your hand over. Sine is y. That's fingers above the bend. How many fingers do you have above the bend? 0. And for sine and cosine, you always divide by 2. Another way of saying it is for sine and cosine, you divide by the total number of fingers. Which, how many total fingers do you have after you bend 1? 4. And that's why it becomes a 2. It's always going to be over that. So it's 0 over 2. Okay, now while we're in the same spot, how many fingers do I have for cosine? 4. So it's the square root of 4 over 2. And then tangent is y over x. How many y fingers did I have? Square root 0. How many x fingers did I have? I had square root 4. So now we'll reduce these. What is 0 divided by 2, or square root of 0 divided by 2? 0. What is square root 4? 2 divided by 2? 1. And then here, square root 4, or square root 0, which is 0, divided by square root 4, which is 2. What's 0 divided by 2? There's tangent's value. Let's roll this up again. Pi over 2 finger. Which fingers are pi over 2 finger? Thumb. Bend your thumb. You're looking at the palm of your hand. When you figure it out, bend your thumb, flip your hand over. Now you're looking at the back of your hand. All right. How many y fingers do you have? Square root of 4. Sine and cosine are always divided by 2. Very good. How many x fingers do you have now? 0. Okay, and now what is the y? Square root 4 and divided by x. Okay, starting at the top. What is square root of 4? 2 divided by 2 is 1. What is square root of 0? 0 divided by 2? Okay, square root 4? 2 divided by 0. What's 2 divided by 0? Undefined. Technically, you should not write equals. I don't know if it'll matter in this course. It will matter when you get to AP Calculus. College Board will not give you credit if you put equals undefined, because undefined doesn't equal anything. So don't put equals. That's why I did not put equal sign. I just wrote undefined. Okay, now let's go to pi. Which finger do I bend? Pinky. Bend your pinky, flip your hand. We have 0. By the way, where is pi located on the unit circle? So if this is 0, this was pi over 2. Where's pi? Okay, because this is going to matter in a second. We're now at pi. Okay, you said it was 0 fingers, so square root, whoops, let me switch to black. Square root 0 divided by 2. What is the square root of 0 divided by 2? We're going to go ahead and reduce. 0. Okay, so right now I'm on this spot on the unit circle. I'm going around the unit circle. We're right there. That's where we're located. Okay, now what about the cosine? How many fingers did you have when you bend your pinky and you're looking at the back of your hand? How many fingers do you have for cosine? Square root 4 divided by 2. But I've done something wrong if I leave it like that. Come over here. What have I done wrong? If I leave it like this. Something's wrong with this number value here. It's negative. Why is it negative? Because it's on the left. So now my x's are negative. So what is the square root of 4 again? That's 2. 2 divided by 2 is 1, but because it's negative, it's now -1. Okay, and what about tangent? It would be the square root of 0 divided by the x takes the negative, the square root of 4. Negative square root of 4. What's the square root of 0 divided by negative square root of 4?
0.
Is it positive 0 or negative 0? It's just 0. 0 is not positive nor negative. Okay, next one. 3 pi over 2. So now I'm moving my dot around. Here I'm now at 3 pi over 2. Which finger is your 3 pi over 2 finger? Bend your thumb, flip your hand. How many y's do you have? Square root 4 over 2. I've done something wrong if I leave it like that though. Why is it negative?
More than 1 pi, but not.
Yeah, it's in between the third and fourth quadrants. It's down low. So y is going to be negative. What value will that reduce to be? -1. Good. Okay. Cosine. What are we going to get for cosine there?
Pi. You have square root of 0.
Square root of 0 over 2, which is 0. And finally, tangent.
Square root of 4 over square root of 0.
Negative square root of 4. It's the negative square root of, negative square root 4 over square root 0, which is undefined. Notice how quickly did tangent repeat its values. So has sine repeated yet? No, we have not repeated yet. It's gone from 0 to +1, 0 to -1. We have not repeated yet. But tangent repeats at 1 pi. It starts repeating. It repeats quicker. Okay. Finally, 2 pi. Which finger is your 2 pi finger? Pinky. Bend it, flip it. How many y's do you have? So square root 0 over 2, which becomes 0. This is the first time we're going to start repeating values. So the next one, oh, let me move my dot around. I'm now 2 pi is right here. So this was 3 pi over 2. I didn't write that. And now we're at 2 pi, which is all the way back around. How many fingers do you have for cosine? 4. So it's square root of 4 divided by 2, which is 1. And now we're positive because we're on the right side of the y-axis. And then finally, what's the square root of 4 divided by this? Excuse me, square root of 0 divided by square root of 4. Square root 0 divided by square root 4 reduces to become 0. And there's your chart. So these are the 5 points for sine and cosine. Notice tangent did not have 5 key points in there. Tangent does not have a maximum. It does not have a minimum. Tangent, you would say in its one period would only have the 2 0, or it only have a 0 within one period. Yeah, only have that 0. Okay. Example 4. Well, now what we're going to do is we're going to start doing some transformations. Okay, so it says complete the table for the 5 key points of the parent function to graph y equals -3 sine 2x. Okay, first question I have for you, this -3. Mathematically, what's the -3 doing to the sine function? Multiplying. Is it multiplying x's or y's? So what I'm going to do over here on rule, put a parenthesis here, leave a blank for the x, and do the comma, and do -3y. That's the rule. We're going to multiply the y's because it's on the outside by -3. And remember, outside's a truth teller. Now, this 2x is inside the sine function. If it's helpful, put a parenthesis around it. They do not have to put a parenthesis there, but that 2x is within the sine function. If anything we're going to come after, they would have to put a parenthesis then if they wanted to include on the inside. But if it comes before the x, it's assumed that it's going on the inside. Inside, is that a lie or a truth teller? Lie. So do I actually multiply the x values by 2? So what I'm going to do is take the normal x values and I'm going to divide them by 2. Okay, so we're going to do that math here. Here are the 5 key points. I've given them to you. These are the 5 key points. Those are already there. We had that on our chart earlier. So this time, all I'm going to do is the math on each point. Okay, so from here, what is 0 divided by 2? Just plug in the x.
0.
It's still 0. What is 0 times -3?
0.
Okay, let's plot that point. It's still 0, 0. Now, pi over 2. We take pi over 2, and now I'm going to divide that by 2. So remember, division, though they are the complete opposite of multiplication, they follow the same rules because they're inverse of one another. So what would it be if it were pi times 2 times 2? It would be not 2 pi. Pi times 2 times 2. It would become 4 pi. You just keep multiplying. Okay, so this time it's pi divided by 2 divided by 2. So it'll be pi divided by 4. That's how the math works. This time it'll be pi divided by 4 because it's pi divided by 2 here, divided by this 2 there. It becomes pi divided by 4. Now I take the 1, and what do I do with my 1? Multiply by -3. What do we get? Okay, so if this is pi over 2, this is pi over 4 here. I'll go ahead and put pi over 4. And we're going to place this point at, whoops, forgot to close parentheses, -3. Put a point there. Next point up. What do I do with the pi? What happens to my pi? Divide by 2. So it becomes pi over 2. And then what do I do with the 0? It multiplies by -3 and it remains 0. So at pi over 2, we have another 0. Okay, let's take this one. This time I have 3 pi being divided by 2, but I divide it by 2 one more time. So what's 3 pi divided by 2 divided by 2?
3 pi divided by 4.
3 pi divided by 4. Very good. 3 pi divided by 4. And I have a -1, but that needs to get multiplied by -3.
Positive.
So 3 pi over 4, which is here, 3 pi over 4 at +3. And now, I've already done, let's do black. 2 pi, and you divide that by 2. What's 2 pi divided by 2? Pi. And what's 0 times -3? So even with transformations, there's still 5 key points. Still just 5 key points, even with transformations. Okay, now if you want to try to connect this best you can, it should round out. So it shouldn't be a V. Whoops, that was my problem with the packet we had the other day, that problem from AP Classroom that we looked at, is that it looked like a V, the data. They just should have given us some data that would round the corners. It shouldn't look like a V. Whoops, it still should have rounded. Well, that's bad. And I'm going to draw my arrow here, just saying it repeats. So On this particular sine function, with the transformations, how long was the period? How long does it take to complete one whole cycle? Pi. So the period is now pi. Now notice, on my normal function, in my normal sine function, what is the period on a normal parent function of the sine function? 2 pi. This one was 1 pi. Look at the inside of the equation. It says to multiply the inside by 2. Did we actually multiply by 2 there?
No.
We divided by 2. By the way, the period comes from the inside. You'll learn that more in the coming classes. So that got, excuse me, that became 1 pi. So even though the 2 was there, this is going to be on your delta map. So I'm really pointing this out. Did I actually multiply by 2? I divided by 2. But here's what that means. It happens faster. So does it actually speed up? Yes. This graph sped up. Smaller number means the graph sped up. Why is that the case? Think of a race. If I'm running, and let's say I'm the parent function, and I take 10 seconds to finish the race, that's the norm. We're just going to say Mr. Voorhees is the norm, and it takes him 10 seconds. And then Quentin runs, and he does it in 5 seconds. My time's bigger than his. Surely I won, right? I'm the faster one?
No.
No, with speed, what's the faster one?
No.
The smaller number. So I want to point this out. The period is smaller. Does that mean it's slower?
No.
If the period's slower, this means it is faster because time period is like a time period. I'm gonna say this one more time because it's gonna come up on the delta math. I don't want you to be going, well, he didn't. This is not right because he's taught us wrong, whatever. I want you to think about it when it comes to period. Period means like time period. The smaller the time period, does that mean it's faster or slower? The smaller the time period, the faster it's going. The bigger the time period, the slower it's going. You got it. So this period is smaller, which means it's faster. By equation, we multiply by 2. Did that mean practically we actually multiplied the values by 2?
No, we divided.
We divided by 2, but that's what made it faster. It's because the number got smaller. Okay. Is there something down below we need to write, fill in? Oh, transformations. What did we do here? We had 2 transformations. Oh, one more thing I want to write on this. Amplitude. I'm sorry, amplitude. Let's write this on. Amplitude. Remember, amplitude, it's the maximum minus the minimum divided by 2. What's our maximum value here? 3 minus, what's the minimum value? Divided by 2. What's 3 plus 3? 6 divided by 2? 3. The amplitude is 3 here.
We can just count the little box.
You could from the midline, as long as you do from the midline, the amplitude is 3. Okay, come down here. Describe the transformations. I don't want you to forget these rules. We have a horizontal dilation. Do you remember what dilation meant? It means multiplication or division. That's right. Horizontal means x's. Horizontal dilation by factor. Now, if you actually divide, you'd say by factor 1/2. That means I'm multiplying by 1, dividing by 2. We had a horizontal dilation by factor 1/2. And what else did we do?
Vertical dilation.
Vertical dilation. Dilation. Now, this is tricky. By factor 3. It looks like I ignored something. A negative is actually not a dilation. What did the negative do? That's right. You'd call that, what's another name for flipping it? A vertical reflection. And they're going to say across which axis? Y'all are good. There you go. There's the transformations. There you go. Let me slide that up so you can see it a little better. So horizontal dilation by factor 1/2. Vertical dilation by factor 3. Vertical reflection across the x-axis. There's our transformations. Little unit 1 review there. All right, the sine function. What does sine deal with? Which letter? I'm sorry. Which letter does what sine deal with? Y. That's right. Okay. I have a DOL for you. Pause it here. Now, as you've wrapped up the DOL for sine. We are going to move on from sine. Now let's take a look at cosine. Now, cosine, what's the difference between sine and cosine? Sine deals with y, cosine deals with x. Otherwise, the graphs are going to be extremely similar. So cosine, the thing I'm going to mark right here is that cosine deals with the x coordinate. Now, how will it look as a graph? As a graph, cosine will look like this. It'll come down, whoops. It'll come down, or it'll start at its maximum, and it'll continue on like that. That's how the cosine wave will look like. The only difference is it starts at its maximum. It doesn't start at 0, it starts at its maximum. Otherwise, they are one and the same. I will show you a graph in a little bit. Many students, the first time they see the cosine and sine graph together, meaning on the same graph, think it looks like the DNA double helix. I'm going to show you that in a little bit because it'll be two waves that are exactly the same shape. It's just one shifted slightly over, and it looks like the DNA helix, double helix. So here's your points. This is not 0, 0. This is now 0, 1. This will be pi over 2, 0. This will be pi -1. This will be 3 pi over 2, 0. And finally, 2 pi, 1. That would be one period. What makes it one period? A complete cycle. You can go maximum to maximum, but the values start repeating. That's what makes a period on a repeating function. We call it a periodic function because it has a period before the values repeat. Now, those are all the points. Well, no, I'm going to wait till the end of class. I'm going to show you something cool at the end. Just going to make sure we get there. So I'm going to pick back up. If you don't have these values, it's okay, because we'll get on the next slide. So here we go. The same table we had earlier for cosine, or for sine, we're now going to do for cosine. So using your hand, you ready? On your hand. Which finger is the 0 finger? Pinky. Bend your pinky, flip your hand. How many x's do you have there? Okay, so it's going to go square root of 4 over 2, which becomes 1. All right. Flip your hand back over. Which one's your pi over 6 finger? Ring. Bend your ring. Flip your hand. How many x's do you have there? So it's square root of 3 over 2, which doesn't reduce any further. That's what it is. Okay. Flip your hand back over. Which finger is the pi over 3 finger? Index. Bend your index. Flip your hand. How many x's do you have there? 1. So it's the square root of 1 over 2. That does reduce to become 1/2. Notice we're decreasing right now. Okay. Pi over 2. Which finger is that? Thumb. Bend your thumb. Flip your hand. We have 0. So it's the square root of 0 over 2, which becomes 0. Now, notice we're on our decreasing pattern, so we should start getting negative values here. Okay, 2 pi over 3. Which finger would that be? Index. Bend it, flip it. How many x fingers do you have there? 1. So it's going to be negative square root 1 over 2. That can reduce to become negative 1/2. 5 pi over 6. Which finger is that? Bend your ring finger, flip your hand. How many x's? Great, we're on the negative end, so it'll be negative square root of 3 divided by 2. Okay, pi. Which finger is that? Pinky, bend your pinky, flip your hand. How many x's do you have? 4. So it's negative square root 4 divided by 2. That reduces to become negative 1. There's its minimum. Now we're going to repeat the values coming back around. So I say repeat, we're going to kind of, these values go in the opposite order. So a 7 pi over 6, which finger is that? Ring, bend your ring, flip your hand. We now have negative square root 3 over 2. We're in the third quadrant right now. That does not reduce. All right, 4 pi over 3, which finger is that? Index, bend your index, flip your hand. How many fingers do you have there for x? 1. So it looks like this, but because we're in the third quadrant, it's negative. That can reduce to become negative 1 over 2. 3 pi over 2. All right, which finger was that? Thumb. We hit a 0, so now we're going to become positive after this. I have 0 x's. There's another 0. Okay, now working our way back up. These are positive values. This is the fourth quadrant because it's on the right side of the y-axis. We'll have positive x's here, positive cosine. 5 pi over 3. Which finger is that?
This one, pointer.
Pointer finger. Bend your pointer finger, your index finger. Flip it. How many x's do you have there? 1. So square root of 1 over 2, which becomes 1/2. Okay, 11 pi over 6. Which finger is that? Ring. Bend your ring. Flip your hand. Square root of 3 fingers over 2. That does not reduce. And then finally 2 pi. Which finger is that? Pinky. Bend it. Flip it. I'm getting square root of 4 over 2. Can that reduce? What's that reduce to become? 1. There it is. Okay. Where will x increase? X's increase starting from pi. Starting from pi, moving forward. We were decreasing until pi. From pi to 2 pi, it increases. So this one's easier to write for increasing. An increase from pi and any coterminal value is the name for that. From pi all the way up to 2 pi, we're increasing. I should have done a parenthesis. I'm sorry. Parenthesis. Increase, decrease, you use parentheses, not brackets. Anytime they use the word interval, when we're not talking about domain or range, you use parentheses. Okay, decreasing. Where would I decrease from? From 0 to pi. So 0 plus 2 pi n. You don't actually have to write the 0. You could just put 2 pi n. From 0 to 1 pi. Looking at this table, where do you see the maximum? At whenever this is 1, which happens at 0. So the max, again, at 0 in any coterminal, which means 2 pi n there. You could simplify. You don't have to write the 0, but I'll just do it. And where would its minimum points occur? Where do you see the minimum? At pi. At any pi, or any odd number of pi's, I could say, you have a minimum value of -1. Now that's the details for cosine. The next slide, just like before, I'm giving you the picture of the parent function. When I take a picture of the parent function, or look at the picture, some of the key points we can identify. How many key points will there be? 5. You'll have the 3's. This one would have 2 zeros here. It has a minimum, and this has 2 maximums. So the points to write out the maximums here. How many radians is this right here? X-axis. 0. This would be 0, 1. This one over here is 2 pi, comma 1. That's the maximums. Okay, we have 2 zeros showing up. Again, we'll have pi over 2 as a 0. And 3 pi over 2. And then a minimum here at pi. Those are the labeled on graph. That's the key points. To fill in the other information, what's the domain for a sine function, a cosine function? I'm sorry. It's all reals. So we're all reals. What about the range? How low does it go? -1. How high? And this would be a bracket because it does include the values. We get there. It doesn't just approach it. We get there. The amplitude. Again, this is maximum. 1 minus minimum. -1 divided by 2, which 2 negatives become positive. 2 divided by 2 is 1. That's our amplitude. And the period. How long does it take to repeat? 2 pi. There you go. So it's very similar to sine. Very, very similar to sine. Okay, let's jump to some transformations here. If you were going to do a rule here, what would you need to do? That 1.5. What do you think happens? That's on the y. You multiply your y's. That's right. I'll go ahead and pause it here. All right, picking back up. Example 7. All right, here, I have a question for you. I want to find this rule for these 5 key points here. What's happening here on the inside with this 1/2? What's it doing to the x? It's multiplying by 1/2. Now, is that what mathematically will actually do to the values?
It'll actually divide.
You'll do the opposite. Instead of multiplying by 1, dividing by 2, what will I do instead? Divide by 1 and multiply by 2, which means I'm going to multiply everything by 2. I'm going to double the x values. Okay, what about the y values?
You just take
Multiply by -2. They're truth tellers. So I'm going to just multiply each y by 2. So as we go down our list here, what's 0 times 2 times 0? -2 times 1. Perfect. There's going to be a point. 0, -2. So cosine starts at either its maximum or minimum without a translation, a horizontal translation. It'll start at either its maximum or minimum. Okay. Pi over 2 here. I need to double it. What's pi over 2 times 2? It's just going to be pi. And 0 times -2. So we have a 0 at pi. There it is. Okay. What about here? Next point. I take my pi and I double it. What's 2 times pi? We're going to have 2 pi and -1 times -2. So at 2 pi, we go up to 2. Okay. How about this next point here? 3 pi over 2 times 2.
6 pi over 2, which reduces to 3 pi.
That's right. 3 pi over 2. Or excuse me, just 3 pi. And then 0 times -2y. 0 times -2. I'm sorry. 0. So 3 pi. Have we had one full period yet? No. Okay, last one. 2 pi times 2.
4 pi.
4 pi. How about 1 times -2? We complete one full cycle at 4 pi at -2. Notice the number is bigger.
It's slower.
This is a slower, whoops, missed. It's a slower graph. This wave is traveling slower. It'll have a lower, we'll learn the word in the future called frequency, a smaller frequency. So the period here is not 2 pi. What's our period? 4 pi. Does that make it faster or slower? Slower. That's right. What was the amplitude?
2.
Good. Okay, what transformations occurred here? We have a horizontal dilation. What did we actually multiply the x's by? And we multiplied y's by vertical dilation. When I say vertical dilation by factor -2? No, I would say by factor +2. What do I do with that negative? It's a vertical reflection. Now, it's a vertical reflection. Which axis do you actually cross over? Across the x-axis. Very good. Language. Okay. Now I should have one DOL left for you. Is that right? But lucky day. Rather than us working here, because we're running low on time, I want to show you something really cool. Okay, so if you scan this QR code, you can go ahead and scan it if you like. I want to show you how the unit circle works together. Now sit down, sit down, sit down. I can do this real fast. Over here, if you scan that QR code, it pulls up this chart. Now I want you to explain this to you. Look closely at my graph, please. What did we call this right here? Okay, now over here I have the graphs of sine and cosine. Notice they look like a double helix, the DNA, double helix. Watch what happens. Here's how this works. As the angle moves around a unit circle, the y coordinate corresponds to sine, which means sine and the circle always have the same height. You see how the purple is sine. Now sit down, look at this. Still got 3 minutes. The y value here always has the same height. You see how this point here has the same height as this graph over here? It's because sine is y. The cosine, though, has a different height. Why? It's x. This x value, this value over here, that's an x, corresponds to this x over here, or this y value over here. Because when I'm graphing it, what's different on cosine is the function values will show up as a y value, but over here, they're actually an x value. So let me go one spot further. When I'm at pi, you can't see it there. Let me go back. Let me just find a different one. Right here, this x value corresponds to this y value over here, but sine always is lined up. So sine will always align with the unit circle, but the cosine will not, because the cosine is actually going off the x value over here, but now it looks like the y value. That's why it looks a little bit off. But that's how they work. In the coming days, we'll talk about inverses. And because you're AP, they're not testing you on triangles, but this is to show you that this triangle would correspond to this reference triangle there. And this would be the case anywhere around. If you notice this point, you can make a triangle. This is the identical triangle. So this is a neat little tool that I've built to show you how all the trig works together as you move around and find values. So again, if you wanted that QR code, it's worth scanning that and saving that to your Desmos account.